Okay, now we're going to take a look at a short little calculator designed to determine whether or not our system has enough NPSH available in its system. So a swimming pool is considered an open system, so it gets 14.7 psi, translates to 34 feet. If we had positive suction head, in other words, if the water level was well above that of the pump and the pump was not pulling any form of a lift whatsoever, we would enter a positive number here. Otherwise, we're going to enter a 0. Our pump has a pressure gauge and a combination vacuum pressure gauge attached to it. And on the suction side, at 1000 GPM, using that same pump we have been looking at 1000 GPM, it was showing 5 inches of vacuum, which is about 5.5 feet. Because we've got that, we do not need to worry about entering any value in here because we don't have to compensate for friction loss. It's already included in that suction reading. The vapor pressure of water is taken from a water properties chart. It's 0.51 psi, and that's what keeps water liquid at 80 degrees in a swimming pool. So then we're going to go in and we're going to now go back to our pump performance curve that we're familiar with now that we've learned how to read these. And there's our pump curve at 1000 GPM. We can see where it crosses the NPSH line. It's just under 9. And if we want to get a really accurate value, the manufacturer is kind enough to tell us NPSH required is 7.92 feet. So we're going to go back and we're going to enter 7.92. Okay, so we have about 19 feet of available NPSH above and beyond. So we are well inside the buffer, and this pump would operate beautifully, quietly, smoothly, very efficiently if it stayed at the design point. But the problem with a lot of these dynamic systems, swimming pools especially, is when you backwash the filter, you remove a significant amount of resistance from the system, and that causes the pump to operate off the curve quite a ways. So what's going to happen is when you take away some 30-odd feet of head, you're reducing the head, and we know that when we do that, we come down and we go across, and we see that we pump somewhere in the 1,300 gallon per minute range. Manufacturer is kind enough again to tell us what that's going to be, and that is found right on the second page of their data sheet, end of curve rated diameter. It's going to pump 1,345 gallons per minute at about 51.5 feet of head. Its efficiency drops to 77%, and the NPSH required goes up to 15.6. Now, two things happened. So we're going to enter 15.6, and the vacuum reading also went up to 8 inches of vacuum. So now the NPSH available is 24 feet. The pump is requiring 15.6. That gives us a buffer of 8.4 feet. It really doesn't quite fit the 10% requirement, but it is above 5 feet. So this pump will probably be okay, but there is a potential that as it wears, it will begin to cavitate. In the upcoming videos and papers, we are going to work through how using a smart pump control system can help alleviate these problems.